Okay, in this video we're going to be learning about arithmetic series. Now we've talked about arithmetic sequences in the past. That's why I have that definition there to review what an arithmetic sequence is. Technically, an arithmetic sequence, what that is that's where we have a set of numbers that are constantly increasing by the same amount, where we're constantly adding the same amount to each term. And we had this explicit formula here that defined an arithmetic sequence. Now, in this lesson, like I said, we're going to learn about arithmetic series. Now, these are a slight difference. It's a build-on to a sequence. Where a sequence is a set of numbers, a series is the sum of the terms of a sequence. So if we had 2, 3, 5, 7, and 9 is a sequence, the series would be the sum of the 2, 3, 5, 7, and 9. So we have a couple of formulas that we could use here, because we could have a situation where we know the first and last term, so we would need to know this first formula, where n represents the number of terms in the sequence. A sub 1 represents the first term. A sub n is referring to the last term. Now, if we don't know what the last term is, if I just know what the first term is and what we're going to be adding each time and how many total numbers there's going to be, we would use this second formula. So let's look at a couple of examples. This first example, it says find the sum of the numbers from 1 to 12. So again, technically this means we want to add up 1 plus 2 plus 3 plus 4 all the way up to 12. But I don't want to do that. I want to use the formula. The formula we're going to use in this case is the n divided by 2 times a sub 1 plus a sub n, the first formula we talked about. So I know there's a total of, going from 1 to 12, there's a total of 12 numbers in that sequence. And I know my first term is 1, and I know my last term would be 12. Well, 12 divided by 2 is 6. 1 plus 12 is 13. Multiply those together, and I get 78. Well, this formula came up, the person that came up with this formula was a mathematician by the name of Charles Gauss. And you'd think that he would have been some old guy running around in a toga. Well, that wasn't the case. He was actually a young guy in 3rd grade, and he was in a class that was acting up. They were causing problems, and the teacher thought that they had this great idea of giving their students this assignment that would take them a while to do in class, to get them to calm down, to get them to settle down as a consequence of their misbehavior. So he told this class, he said, I want you guys to add up all the numbers from 1 to 100. Well, little Charles Gauss sitting back there with his slate in his lap, in just a couple of minutes, wrote down 5,050 as his answer, and the teacher was amazed, and come to find out, this is what the little boy, Charles Gauss, was able to do in his head. What he did is he realized, well, if I take and add the first number plus the last number together, and if I divide the number of terms, 100 numbers that he would have to add together, divided by 2, that would give him 50. So if he multiplied those together, he realized that you would end up getting 5,050. And essentially, this is the formula that he came up with that he worked out in his head. And as a result, like I said, Gauss grew up to be a major mathematician. In fact, by the time he turned 18, he came up with the fundamental theorem of algebra, which we've talked about in the past. Now, let's say if we had a situation like this one. An auditorium has 20 rows with 14 seats in the first row and 2 more seats in each additional row. How many seats are there in all? So here's a scenario where I know that my first term is not 1. My first term is going to be in the first row. There's 14 seats. I don't know how many are in the last row. That we don't know, so I can't use that first formula. But I know that there's a total of 20 rows in the auditorium, and that my constant difference between each row is 2 seats, because every row we're adding 2 more. So I can use that second formula that we talked about, the one where it was n divided by 2 times the first term plus your constant difference times n minus 1. So n is the number of rows, so I'd have 20 rows divided by 2, or 10. And then 2 times my first number of my sequence, which is 14 seats in that first row, plus 2 times 20 minus 1. Again, I can do a lot of simplifying here. This would be the same as 10 times 2 times 14 is 28. 20 minus 1 is 19. And 19 times 2 would be 38. 28 plus 38 is 66. So there'd be 660 seats in the auditorium. So why don't you guys take a minute and try this next one on your own. So here we have an auditorium that has 24 rows with 10 seats in the first row and 3 more seats in each traditional row. How many seats would there be in all? So why don't you guys take a second and pause the video and hit play when you're ready to check your answer. Okay, in this one we know that our first term would be how many seats there are in the first row. There's 10 seats in the first row. Well, we don't know how many seats there are in the last row, so we don't know a sub n. But I know n is that there are a total of 24 rows. And we know that our constant difference here is 3 because we're adding 3 seats each time. So when you set up your equation, you should have set it up like this, where it would be 24 divided by 2 times, and then in parentheses, 2 times your first term, which is 10 or 20. 2 times 10 would be 20, plus your constant difference, which is 3, times n minus 1, which would be 9. So when you work all this out, you should have ended up getting 1,068 as your answer. So there's 1,068 seats in the auditorium. Now, all of what we're doing could be represented by what's called summation notation or sigma notation. So you might want to pause the video so you can make sure you get all this written down. But here we should recognize this symbol. The symbol here is the sigma, or the symbol sigma, which represents the word sum. You'll see that in spreadsheets, like in Excel. You'll see that symbol. So that would find the sum of a set of numbers. So we're going to use this to represent the sum of a sequence, where I down here, this represents the first term in your sequence, your starting term. It does not always need to be 1. Sometimes you'll see something like this. This means you're starting with the third term in the sequence. The number that's on top of the sigma symbol, that represents the last term number. So if it's 30, that means that you're ending with the 30th term in the sequence. Now this is our rule. That's what we call our rule. That's usually going to have an explicit formula there where if you want to find out what the first term in the sequence is, you'd have to put 1 inside that explicit formula to find the first term. If you want to figure out what the last term in the sequence is, you're going to have to put that number into the explicit formula to find out what the last term in the sequence would be. Now we could have written where we had to find the first 12 numbers in example 1. We could have written that like this, because our first term, we would start with our first term, and there's 12 numbers we're adding together, so there's 12 terms in all. The rule is that there is really no rule. There's really nothing that we're doing to our term number, so I would just put, to find the first term in the sequence, I would put 1 in here for I, and I get 1 as my answer. To find the last term in my sequence, I put 12 in here for I get 12 as my answer. So this is how you could have written that. This is sigma notation. So this represents the sum of the numbers from 1 to 12. So let's say if we're given this scenario, we have to find the sum of the first 500 terms for the sequence represented by 4i plus 6. So again, this does not mean that we just add together 1 plus 2 plus 3 all the way up to 500. This means that we start with the first term and we end with the 500th term. Well, in order to do that, I want to use that formula that we talked about in the beginning there. But first, in order to do that, I need to find the first and last term. So to find the first term, you put 1 in that sequence. 4 times 1 is 4, plus 6 gives me an answer of 10. To find the last term in the sequence, I put 500 in that formula. So 4 times 500 is 2,000, plus 6 gives me 2,006. And now I'm going to plug it in that formula. So my n is that, well, there's a total of 500 terms here, divided by 2, times my first term, which is 10, plus my last term, which is 2,006. So when I simplify this, I'd end up with 250 times 2016, which we would need our calculator, but you should get 504,000 as your answer. So that's it. That's our notes for today. This is, again, this was all about an arithmetic series. A little side note, if you didn't recognize, in your assignment, you're asked to do just questions 1, 2, 5, 8 through 11, 14, and 15 on the front side of your assignment. On the back side, you're just going to do 16A, 17, 18, and 19A. So with that, good luck on your assignment.